Let's say you want to know the probability of a trait being passed throughout a whole family rather than just parents to offspring, like so down here. This is called a pedigree or a family tree. On a family tree, a female is a circle, a male is a square. If somebody has the condition we're looking at, or disease, they're shaded in. If they do not have it, they are empty. Some pedigrees will fill people in halfway, like so, if they are a carrier, if they're heterozygous, for example. If this was H's, big H, little h, they'd show that they're half shaded in. Looking at the pedigree below, draw the difference between a marriage line and an offspring line. So here's a male and a female that are married. And so to be married, the line is right in the middle and it connects the two. To show that they had kids, you can see here, so between the marriage line you drop down and then you create this little vertical line that connects each sibling. I'm only going to give this one up here 3 kids, so I draw a horizontal line, 3 little vertical lines, and I'm going to give them a son and 2 daughters, like so. Okay, marriage line is in the middle, and offspring line is a little more complex. On the pedigree below, label the generations and each person's number. So this is our first generation. You have to use a Roman numeral. Our second generation is the second row, and our third generation is down here. We need to look at each person then. We go from left to right and just number them. 1, 2. We start over here. 1, 2, 3, 4, 5, 6, 7, 8. Down here, 1, 2, 3, 4, 5. And this allows us to talk about people. So for example, this person, we could call, if we don't know their name, we could call this person, person 3, 3. This person right here, we could call 2, 3, etc. We'll use that down here. Okay? Now, something to point out in terms of siblings, brothers and sisters, the oldest is to the left and the youngest is to the right. So here we have a daughter that got married, so the person that married in doesn't count. This daughter is the oldest, and then a son got married, daughter, daughter, son, youngest. Okay? Pedigrees can be used to trace and predict the probability of traits. So let's fill in the rest of the genotypes here. So let's say that this disorder, and I know it says tongue rolling down here, just ignore that for now, is a recessive disorder. And so in order to have it, you have to have 2 little t's. If you have the disease, you get filled in. So this person has the disease. What's the genotype of this person? Well, it has to be little t, because if it's recessive, you have it filled in. This person is little t, that one, this one, that part's easy. I gave you this person here, big T, little t. Okay? In order to not have the disease, you have 2 options, big T, big T, big T, little t. Now this son, we don't know which one he is unless we look at a Punnett square. So let's do a Punnett square for these parents, big T, little t, and multiply it out. Big T, big letter first. Big T, little t, little t, little t, little t, little t. To not have the disease, you can be this or this. Now, is this combination even possible from the parents? No. Therefore, this son must be big T, little t. Same thing for this daughter, because it's coming from the same parents. Big T is not an option. And then here for this son. Okay, then with people that get married in, it can get a little more complicated because we don't know what they're bringing in. We could use probabilities and we can figure it out. For now, I'm just going to stop there. Don't worry about this one. Let's look here. If this child is little t, okay, what's this parent have to be? Well, let's do a Punnett square. If this parent was big T, and they married a little t, what are the possibilities? They would look like this. That means that all of their children, 100% of their children would be big T, little t. Is that what we have here? No. That means this parent must be big T, little t. And in order to double check, you could do another Punnett square. little t, just to show that if I figure this out here, yeah, there's a chance here that their child could be little t, and have the disease. It works out. Okay? So using the generation person numbers, it says who cannot roll their tongue. I need you to cross this out. It says who has the disease. So this person has the disease. They are generation 1, person 1. Here we have generation 2, person 2. Generation 2, person 3. Generation 2, we're still in the same row, same generation, person 7. Down here we have generation 3, person 3. So all these people have the disease. Now let's look at relationships. Person 3, 1. Here's person 3, 1. What's their relationship? Man, I made a lot of mistakes in this note packet, so please fix this. Person 3, 1 and 3, 2. What's their relationship? Person 3, 1 and 3, 2 would be sister and brother. Right? Because they're siblings, they're connected by an offspring line. Here, how about person 1, 2 here and person 2, 4? What's their relationship? Well, let's take a look. Mom, dad, child, son, specifically, child. So person 1, 2 is the mom because it's a circle. And person 2, 4 is the son. Person 1, 1 up here and person 1, 2. What's their relationship? We have husband and wife. And then last one, person 1, 2, person 2, 2, here's generation 2, person 2, and 3, 4. This one's a little tricky. What I like to do is put myself in this person's place. So this, let's say this is me, female, okay? These would be my parents. This would be my parents' brother, so it's my dad, my dad's brother, my dad's sister. So my dad's sister would be my aunt. So this would be aunt to niece. You need to be able to interpret these things from a pedigree. Okay? So now you're going to come up after you finish this page, LO6 conference, come with the page done. You're going to look at tongue rolling. Now I should have used a disease, it works a little bit better, but just for the sake of humoring me, tongue rolling is dominant. Not being able to roll is recessive. So big T or big T little t can roll. Not being able to is little t. And I shaded this backwards. It was stupid of me, but just follow along with my pattern, okay? So for example, the father can roll his tongue. I shaded him in. So in this case, I said shaded equals rolling tongue. Just follow the pattern. If you need help, see me and I can walk you through it. So you're going to figure out genotypes for each possibility and then answer some questions here and then conference with me when you think you have it. And if you get stuck, come see me and I'll walk you through it. I also want to point out that for LO7, you're going to be looking at how genetics relates to the real world. So there's a variety of articles that have to do with genetics. You pick one to read. And then there's a question sheet that goes with it. All the articles are in one folder in the crate, so pick the one that is interesting to you. If all of the articles are gone for that topic, you need to pick something else. There's a limited selection. Then there's an extra sheet where you fill out some questions and some information about the article. Make sure you grab that. On the date on the calendar, we're going to have a class discussion, so come prepared by that day to talk about your topics and how this relates to real life. You can also do some extras for extra credit. Then, down here, no concept map, no test, you're completing a pedigree project, and that's what the rest of this packet is. That it's all about the pedigree project. There is a video for each section, so you need to watch. There's 3 parts to the project. Watch the video for each part as you go so you know what you are doing. Okay? So get going. If you have any questions, come see me. I can help you through this. There is also a worksheet that goes after the conference. Let me know if you need some help.